Ett kraftpaket har flyttat in på Kungliga Tekniska högskolan i Stockholm. Superdatorn består som är 6 gånger snabbare än sin företrädare, superdatorn Lindgren. När den är helt färdiginstallerad efter nyår klarar den nästan 2 petaflops, vilket gör den till Nordens kraftfullaste superdator för akademiskt bruk. Än så länge är den bara svart, men snart ska den få ett specialdesignat yttre för att hedra sin namne Elsa Beskow. Men vad finns egentligen innanför det svarta skalet?
Inside you have a total of over 53,000 processing elements, cores as we call them, that are all slotted in these little modules. Those are the interconnection cables. Those are the cables that make the individual processors speak to each other so they can exchange information and allows you to use the system as if it was one big computer. So this is really what makes this a supercomputer as compared to a distributed system where you just try to have lots of individual computers on the internet, say. They are essentially running Linux. There's a special version of Linux that Cray did for these supercomputers, which takes away a lot of the stuff that you would have on a normal Linux system, like a printer driver, for instance. You don't really need for these supercomputers.
Ventilationen går för högtryck, det blåser i håret här inne. Lagringen ligger separat för att inte slöa ner superdatorn. Och nere i källaren finns reservkraften, men där är det betydligt tystare.
We use a lot of power for our computers, and the diesel engines are not enough to really power everything. So they just keep essential services up and running, but Beskow, for instance, will be gone. So if we don't have power, then no computing, unfortunately. We pay about 10 million crowns a year just for electricity. So it's a substantial amount of our budget that just goes into the electricity bill. The lifetime of the system is now 4 years. That's also what we have the budget for. And these supercomputers are on the leading edge of technology, but still they are production systems. So we want to have a system that is stable, that our scientists can use from day one, that we have the system installed. So I will not foresee any major exotic things happening in the next 4 years. So I don't think you will see holographic storage. I don't think you will see a quantum computer here. What you will see is a computer that will be much more powerful, in this order of 6 to 10 times more powerful, most likely. Essentially, it's very similar technology, just more.